All right, so we are going to discuss radicals. And while we do that, we're going to have a couple of different things we're going to talk about. So with radicals, in terms of what you need to know about radicals, well, first of all, try to figure out what they are. Okay, and there'll be a series of videos, but we'll talk about the notation to do with radicals first. Then we'll talk about what we do with them, and that's the operations. So we'll call them operations, but we're talking here about adding, subtracting, multiplying, and dividing. And then we're going to talk about solving equations. So those are kind of the three different things you have to be able to do with radicals. All right. So we're going to start with a notation and the concept of a mixed radical, an entire radical, and those kind of things. We're going to work off of the textbook, so you'll see me flip to the textbook a few times and back again. But what we have to know first in terms of a radical, what is a radical? And you guys are used to square roots, so that's kind of the idea of a radical, but there's out here there can be a number, right? And that number is called the index of the radical. When you don't see a number, it's considered to be a square root, and there's a 2 in there, even though it's not written. But if there's a 3 in there, it becomes a cube root. If there's a 4, it becomes a fourth root, and so on. And then in here is the radicand. Okay? And that is the thing you're actually taking the root of, whatever root it happens to be. So there's an index and there's a radicand. And so, for example, we'll do something that you guys are familiar with. What's the square root of 9? So we say, well, that's 3. That's an easy one. Okay, but you could have the cube root of 27. Okay, and then you have to know that that's 3, because 3 cubed is 27. You could have the fourth or fifth root, so you can have a different index up there, and you may not be used to seeing that, but all it means is the cube root of 27 is 3, because if you translate it into exponential form, 3 cubed is 27. So the index of the radical becomes the power of the result, to get back to the radicand. Okay, so that's the idea in terms of just what we're talking about. What is it that we're talking about? We're talking about a radical. So you can see different values on the index and different things in here, and you'll see we're going to even do things where we're going to say, what's the square root of x to the fourth, for example, and you'll have to know that that's x squared. Okay, and we'll get to why that's the case in one of the videos, but that's the idea of what is a radical. What are we talking about? So when we're talking about radical expressions, we're talking about index, then the root sign, and then the radicand. Okay, now there are two types of radicals that we're going to talk about. The first is an entire radical. And an entire radical is everything underneath the root sign. So an entire radical is something like the square root of 25x cubed. Okay, that would be an entire radical. So it's something where everything is underneath the root. And then you have a mixed radical. And a mixed radical is where you have things under the root, but then you also have things that are not under the root sign. Okay, so you have, for example, 3x and then the fourth root of 5. Okay, that's a mixed radical. And in order to work with radicals, we have to know how to switch from one to the other. So how do I go from an entire radical to a mixed radical, and how do I go from a mixed radical to an entire radical? So if I have something out here and I want to put it inside the root sign, or if I have things in here that I can simplify. Okay, so we're going to talk about how to do that. So let's talk about how to convert between them. Okay, because that's really what we have to be able to do. We have to be able to convert mixed to entire and entire to mixed. So we'll start with going from mixed to entire radicals. And the reason you may want to do this is because you may want to multiply or divide them or something like that, and you want to see what they look like when they're both under the root sign, okay? So if we want to go from mixed to entire, so we'll just put an example here to follow so you can kind of see how this works, but we'll do our 3x and then fourth root of 5, okay? That's a mixed radical. I want to make it entire. So the first thing you're going to do is you're going to take this part, all right, and you're going to write it inside by raising it to the power of the index of the radical. So we're going to take, and I'm going to use simplified language here, we're going to take the term outside, and I apologize for the poorness of my writing. Maybe I can actually type this instead. It's probably going to be easier. So we'll take the number that is outside, or the term, it's not necessarily just a number, so we'll say take the term outside the radical and raise it to the power of the index of the radicand, or the radical, okay? So what does that mean? So what that means is, in our example, is we're going to take our 3x and we're going to raise it to the fourth power. We're going to try to figure out what that is, okay? So that's 3 to the fourth times x to the fourth. Okay, you remember your exponent laws, hopefully. And then 3 to the fourth is 3 times 3 times 3 times 3, so it's 81 x to the fourth. So that's the first thing we're going to do. Then once we've done that, the second step is to write that inside of our radical. So we'll type this so that you can make out what I'm saying and make it a little bit quicker. But we're going to then multiply the result by the number, we'll say not the number, we'll use the radicand, okay? And we'll say writing the whole thing under the root. And that's it. So in our example, we're now going to go, okay, we have our 3 to 4x to the 4, so we're going to write our fourth root, and then we're going to go 5 multiplied by, because we're going to multiply the radicand by this, 81x to the fourth. And 81 times 5, we've got to figure out. Here we go, okay, well, that's 405, because 80 times 5 is 400, and 1 times 5 is 4, or sorry, is 5, not 4, x to the 4. And that is now an entire radical. Okay, so that's how you write a mixed radical as an entire radical. Okay, so we're just going to flip over to the textbook for a second. I'm going to zoom in a little bit so you can see this, but we'll just talk through a couple of the examples that are in your textbook. So here's the first one. It says express each mixed radical in entire radical form, and the first one is 7 root 2. So I take the 7 and I write it to the power of the index. Now there's no index there, right? It doesn't say anything, so it's got to be a 2. So we take 7 squared, then we multiply that by 2. So 7 squared is 49, we multiply it by 2 and get 98. All right, same thing with this one, a to the fourth, square root of a. So we take a to the fourth and we square it, and that gives me a to the eighth, and then we multiply it by a, and you get a to the 9. All right, this one, it's a cube root, so we're going to take 5 cubed b cubed. 5 cubed is 125, so if you go down, you can look at the answers here. But we're going to take 5b, we're going to cube that, so we're going to get 5 cubed b cubed, okay? And 5 cubed b cubed is 125b cubed, and then we're going to multiply it by 3b squared, and it's going to end up giving you this. Now you might be looking at this saying, well, it seems like they're doing a lot more than what you're telling me to. They are a little bit. They're writing it out in more steps, but it's pretty much doing what we're doing. It's just doing it in a little bit of a longer fashion. Okay? So if we just do a couple more examples just to sort of see, you'll see that down at the bottom of your textbook page, and I'm on page, let's see, what page am I on? I'm on page 274 of your textbook, it looks like. So here's one, it says 4 root 3. The next one says j cube root of j, and then 2k squared cube root of 4k. So let's do those ones, and we'll just do the last one because I'm going to run out of time. So I've got 2k squared onto the cube root of 4k. So if we look at that here, we have 2k squared, and then it's the cube root of 4k. So I'm going to take 2k squared, and I apologize for the writing here, it's not very good, but we go 2 cubed times k to the 6th, because 3 times 2 is 6. That gives me 8k to the 6th. When I cube 2, I get 8, and when I cube k squared, I get 8k to the 6th. And then I'm going to take that, and I'm going to multiply it inside. So
this is
4k.
announcement. Students who should be in the grad photo, you should be making your way right away. And those who are not in the photo, you should be in your classroom, and study should go on as normal. Thank you.
So I'm going to put 4k times 8k to the 6th, and that's going to give me the cube root of 8 times 4, which is 32, and k to the 6th times k, which is k to the 7th. So that's how you make a mixed radical an entire radical.